Hi Algebra 2, this is Unit 5, Lesson 3, and today we're going to talk about the summation notation. So a lot of what we're going to do in this unit involves adding terms together in a sequence. So we have this new notation called sigma notation, all right? So sigma notation or summation. My symbol is this funky looking E right here. It is a button in your calculator. Let's go through what each of these numbers is. The number on top is going to be the last term. The number on the bottom is going to be your first term. And this 2n is basically my formula for the sequence. All right, so again, this is the letter sigma. It's a Greek letter. It looks like that funny E, and it denotes the sum. So basically, I'm going to start with 1. I'm going to plug it into this formula, and I'm going to keep on going. I'm going to add, and I'm going to plug in 2, 3, 4, and 5. The last term that I'm going to plug in is 5 into this formula, and I'm going to find the sum of all those terms. All right, so let's try it. So I'm going to plug in 1 for n, 2 times 1. And then I'm going to plug in 2 for n, 2 times 2. I'm going to plug in 3, and I'm going to keep on doing that. And the last term that I'm going to plug in is 5. So basically, I want to add all these together. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So I'm going to add 2 plus 4 plus 6 plus 8 plus 10. And you can put those all into your calculator. Now this summation notation is also in your calculator. So let me show you that. If I grab my calculator right here, it is the math key. So if I hit math and I scroll down, see the summation right here? And I plug in all of my terms. So basically this is going to be x. And my first term, it's a little hard to do it on the iPad here. My first term is 1. My formula is 2x. Notice I'm substituting an x instead of n. And my last term is 5. And I hit enter, and it does all the work for me. Okay, but we're going to do these out by hand, but I did want you to see it on the calculator as well. All right, so back here, let's try these summations that I have. So this one is similar. A, I'm going to plug in 3. So 2 times 3, and then I'm going to plug in 4, 2 times 4. This is the formula that I'm using right here, and I'm going to stop. My last term is 5. So these are all short, easy ones. If you want to check them in your calculator, you certainly can check them in your calculator. Okay. So again, the first term's on the bottom. So my first term on B is -1, and my rule, my formula is right here. So I'm going to plug in -1 and square it. And then I'm going to plug in 0 and square it. And I'm going to plug in 1 and square it. 2. And my last term that I'm going to plug in is 3. So -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And I'm just adding all of those up. Okay, so it's pretty easy. And then for C, my first term is -2. Now look at my formula for C. My variable is the exponent. So this is going to be 2 to the -2 plus 2 to the -1 plus 2 to the 0 plus 2 to the 1 plus 2 to the 2. So my first term, I'll just get a different color here. This is my first term. And this is my last term. And I just add those all up. 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 squared is 4. 4, 5, 6, 7.5 plus 1/4 is really 7.75, but you can always throw that all into your calculator. All right. Here's a multiple choice. Which of the, represents the value of? So I have the summation. I'm going to start with the number 1. This is my formula that I'm plugging it into. 1 over I. So I'm going to do 1 over 1. then I'm going to do 1 over 2, then I'm going to do 1 over 3, and the last term I'm plugging in is 4. Now that you could put these all into your calculator, but also if I wanted to add them up by hand, I would need a common denominator, so I'm going to make all of them have a denominator of 12, so then I can add them up. So I have 12 over 12, 6 over 12, 4 over 12, and 3 over 12. And I add those all together, and I get 25 over 12. All right, flip over to the next page. We have a few more to try, just so we make sure we have the idea of this summation. All right, so this is definitely a little bit harder. I want to express each sum using sigma notation. Use I as your index variable. First consider any patterns, so I got to look for patterns involving the terms. Then work to put those patterns into a formula and a sum. So if I look at all of these numbers here, 9, 16, 25, 100, think about what they all are. Those are all perfect squares. Right? 3 squared is 9, 4 squared is 16, 5 squared is 25. So this one's actually not too bad to do. So my first number is 9, so that means the first thing I squared was 3. And my rule, my formula is I'm taking that term and I'm squaring it. The last term, right here, my last number is 100, and that would come from 10 being squared. So that's my last term. All right, so the first one was a nice, easy one to do. Next one is definitely a little bit more complicated. If you look at these, each time I am adding 3. Adding 3, adding 3, so I'm adding 3 each time. All right, so, but this is a little bit harder to do. There's a couple different ones that you can do. Say I wanted to start with 0 being my first term. Okay, but look at the value. I got -6 out of it. So the formula would have to be -6 plus 3k. All right, plug in 0. 0 plus -6. Plug in 1. 3 times 1 is 3 plus -6 is -3. My last term is, the last value is 15, and that would result from putting in 7. So 3 times 7 is 21 plus -6. So a little bit more complicated, even though I'm only adding 3 each time. That first value is -6, so I had to play around with it a little bit. Definitely easier if it's multiple choice. So exercise 4 is a multiple choice one. So basically you can just test these out to see what gives you. So like test out choice 1, plug in 1, 3 to the 1 power is 3. Okay, that works. Plug in 2. 3 squared is 9. Oh, nope, because these are the values. These are the values that I'm looking to get out when I plug in, so 1 didn't work. Try 2. Plug in 0. 2 to the 0 is 1, times 3 is 3. Plug in 1. 2 to the 1 is 2, times 3 is 6. Plug in, what am I up to? 2. 2 squared is 4. 4 times 3 is 12. Oh, it looks like this is working. Plug in 3. 2 to the third is 8. Times 3 is 24. There we go. We got a winner. Okay, so you're just testing it out to see what works or not. All right, last problem. Consider the sequence defined recursively by a sub n equals a sub n minus 1 plus 2 times a sub n minus 2, and they give you the first 2 terms. So basically, let me get a pen, a sub 1 is 0, okay? A sub 2 is 1. A sub 3 is the previous term, right, which is a sub 2, plus 2 times the previous term before that. 1 plus 0 is just going to be 1. A sub 4 is the previous term, a sub 3. Let me write this out because in case I'm losing anybody. It's the previous term plus 2 times the term before that. So I'm just plugging in. The previous term is 1. 2 times the previous term before that. 1 plus 2 is 3. Okay? A sub 5 is the previous term plus 2 times the previous term before that. The previous term was 3. 2 times the previous term before that was 1. So 3 plus 2 is 5. You can see this is time consuming. A sub 6 is the previous term plus 2 times the term before that. The previous term was 5. The previous term before that was 3, but I'm multiplying it by 2. So that gives me 11. And the last one finally, because look, my last term is 7 right here, is the previous term plus 2 times the previous term before that. Previous term, a sub 6 was 11, and 2 times a sub 5 was 5, so that is 11 plus 10, which is 21. Okay, and now let's look at my summation. So basically I'm starting with 4. Okay, so where am I starting with? I'm starting right here. I'm starting with a sub 4. A sub 4 is, this is what I'm doing. That looks a little funny. But I'm starting with 4. And that's going to give me 4 was 3. And then I want the 5th term, which was 5. And then I want the 6th term, which is 11. And then I want the 7th term, which is 21. So I'm just adding up all those numbers together. And there we go, 40. All right. And that is it for today. We will practice that tomorrow.